In this video, I'll be covering question 4, part C from the 2019 AP Calculus AB Free Response No Calculator Allowed section of the test. I cover parts A, B, and C in their own individual videos, so if you want to see those other solutions, please check out my other videos. Alright, so at part C here, we're talking at time t equals 0 seconds, the height of the water is 5 feet, and then they specifically, it's always nice when they tell you exactly what to do. They're saying use separation of variables to find an expression for h in terms of t. So that means we need to take our derivative equation here and do what they say. We want to separate this out by its variables, and then we're going to end up taking an antiderivative of both sides, and that's going to get us to our original equations. And this is the type of problem where they give us an initial value here, and we'll use that initial value to find that plus c that you always have when you're taking your antiderivatives. So first things first, we want to get our h's on one side and our t's on the other. I always like to just go ahead and start off by getting the dt over to the other side. So multiply both sides by dt to cancel it out there. Then we get negative 1/10 square root of h dt. And now I'm going to move my h's over to the other side. Essentially, I'm multiplying by 1 over the square root of h to cancel it out over here. That gets me 1 over the square root of h on this side. So we have 1 over the square root of h dh is equal to, those will cancel out, and so we've got negative 1/10 dt. So step 1, we've separated this out into two separate problems. And now to cancel out those dh's and dt's, this is when we go ahead and take the integral of both sides. Looking at the left side first, you always want to be on the lookout for a handful of algebraic rewrites when you're doing integrals or derivatives. And so what we're actually going to see here is both rewrites on this left-hand side. We've got a rewrite for roots. So anytime I have x to some power inside a root, I rewrite that to x to the power divided by the root. So if I had something like the cube root of x to the 5th, I would want to rewrite that as x to the power of 5 over the root of 3. The other rewrite you're always on the lookout for is whenever you've got a number over x to a power, you want to bring that x up from the bottom to the top and make that power negative. So if you had something like 5 over x to the 3rd, you would want to rewrite that as 5x to the negative 3. So I'm going to do those rewrites. I'll do them in two bite-sized little pieces here. Once you've seen it once, you should probably just be able to do it all in one move. So the first thing I'll do is I'll use my power over root rewrite. So that's a power of 1 and a root of 2. So the first move here to be rewrite this is 1 over h to the power of 1 over the root of 2, h to the 1/2. Nothing happens on the other side. We'll just kind of leave that alone for now. And then we're going to use our second rewrite move here to bring that 1/2 h to the 1/2 from the bottom to the top. So we'd rewrite this as 1 h to the negative 1/2 dh equals the integral of negative 1/10 dt. So this was just a rewrite into another rewrite. And now that we're there, now we're going to treat these like two separate problems, one on the left, one on the right, and we're just going to apply our power rule for antiderivatives here. So the power rule says add 1 to the power, divide by the new power. So I add 1 to the power here, that's going to get me h to the 1/2, and then divide by the new power. Normally you would want to put a plus c right there when you're doing indefinite integrals. But when you've got this separation of variables method, you only need 1 plus c for the full equation. And usually it is best to put that plus c on the right-hand side over here. So we're going to go ahead and leave the plus c off on this side, and we'll just have one giant plus c on the right-hand side. Doing the power rule on the right-hand side, anytime you've got a number by itself, that just gains a letter back. So this is going to be negative 1/10 t, and we'll go ahead and now put in our plus c. So from here, what you're going to want to do is this is where that initial value portion comes in. Remember that they gave us an initial value. They told us that when we plugged in h as 5, that t should be 0, and that's what should give us out our plus c. So what you're going to do is you're going to plug those values in and solve for your plus c. I would do one little move of algebra before I get going. Again, it's better to do these little moves ahead of time, and it'll just make your life easier. So this 1/2 on bottom, you actually would flip that. This would be a 2 over 1 times h to the 1/2 equals negative 1/10 t plus c. So now I'm going to come in and I'm going to sub in these values. So for t, I'll put in 0. For h, I'll put in 5. So I get 2 times h is 5. So this would be 5 to the 1/2 equals negative 1/10 t is 0 plus c. So then on the left-hand side, I get 2 times 5 to the 1/2. Remember that 5 to the 1/2, if you undo that, that's the rewrite we did really back up at the beginning. That's our square root rewrite. So this would be the square root of 5. So we would say 2 square root of 5 equals, this would zero out, and we end up with c equals 2 root 5. From here, what you want to do is you want to bring this c back and you want to go ahead and plug it into this equation right here. So we're going to bring this together with this, and we're going to use that information to solve for our final equation, what our h equals equation is. So working from this, we would have 2 h to the 1/2 equals negative 1/10 t, and then our c value here that we'll plug in for would be plus 2 root 5. Now we're just going to solve this to get h by itself. So I would start by dividing by 2. Essentially, you're multiplying this entire equation by 1/2. So we get h to the 1/2 is going to equal, distributing that 1/2 in, 1/2 times negative 1/10 is going to get us negative 1/20 t plus the 2 up here and the 1/2. Those are going to cancel each other out, and we've got the square root of 5. Then the last thing is we need to get rid of that 1/2 on our t, so we would end up squaring both sides. You want to get h to the power of 1, so whatever I do to one side, I have to do to the other, and we're squaring that whole equation. So we'll end up with h equals negative 1/20 t plus the square root of 5 squared. And then oftentimes they want you to write it sort of in function notation, so you would say h of t equals negative 1/20 t plus the square root of 5 squared. So out of here, this is actually a 4-point problem. The first point is going to come from when you separated out your variables to begin with. You'll get 1 point right there. You'd get 1 point for making it all the way down here to getting out the actual antiderivatives. You'd get 1 point for getting that c value correct, and then you'll get 1 point for getting out that final answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.